Okay, let's work a problem using Wien's law, and this is the use of this law is going to be to enable us to try to figure out the temperature of some astronomical object we look at. Like, for example, this thing you see right here. We're looking at an image right here that was obtained from the Chandra X-ray Observatory. But let's put in some hypotheticals. Let's pretend that Chandra had somehow been able to measure the peak of the spectral distribution of this, where the distribution of all the different X-rays that come from this object happen to have its maximum. And let's just say that that peak turned out to be 1.4 nanometers. That's in the X-ray part of the spectrum. Could not see any of that light using a visible telescope. This is an X-ray image that was created by showing us where in the field of view the brightest number of X-rays strike the detector, and it looks like this kind of thing. So let's try to figure out if we had found that this had a peak at 1.45 nanometers. Let's figure out how hot this object is. And the way to do that, of course, is to use Wien's law. And Wien's law is going to involve using this law. That is, we're going to know that the peak wavelength, the lambda maximum, is going to be given by 2.9 times 10 to the 6th divided by the temperature of the object in Kelvin. So, you know, we're going to start out and we're going to say that we know that that peak, we know what that is. We know that it's 1.45 nanometers. So what we want to do is find this. That's what we want to know. So use our algebra skills. We know that T is going to be given by 2.9 times 10 to the 6th divided by the peak wavelength. And if you don't know how I got to this point, you need to look back at your notes, practice a little algebra, and be sure that you can do this. So let's do that. Let's stick this in. The number is going to be 2.9 times 10 to the 6th. And we know that if we measure the peak in nanometers, 1.45 nanometers, the temperature will come out to be in degrees Kelvin. So divide this. That's pretty easy to divide. 1.45 divided by 2.9 comes out to be 2. And of course the 10 to the 6th remains. We found that this object has a temperature of 2 million degrees kelvins. And typically when you look at something with an X-ray telescope, that's what you see, and Wien's law is crucial in letting us do that calculation.